All right, so apologies for not being around for your fabulous work days you're going to get here. But a few of you did ask some questions, and let's start on the page 30 assignment, which is our 1.3 bookwork. People asked me to look at number 3, number 9, and number 31. So if that does not interest you, get out of this part of the video. But let me get to the right page, my book. All right, so looking at number 3, the directions, which I know sometimes we change directions, so look carefully at your blue sheet. Looks like, oh, not on 3, but coming up there are some things that say ignore the instructions, so we'll get back to that. All right, so 3 and 9 are probably the same kind of questions. Let me look. Yep. So they want you to determine if the function is continuous at the given value, justify with, okay, so ignore all the continuity test business. I just need you to determine if it's continuous or discontinuous, and then if you want to get really crazy, maybe tell me why, or what kind of discontinuity you have. So on number 3, the function is, I can't read it, h of x equals x squared minus 36, whoops, over x plus 6. So when you have what we call a rational function, the only issue it's going to run into for continuity is the denominator. Remember, the denominator cannot be 0. So the value that they want you to test for continuity is x equals negative 6 and x equals positive 6. So this is just like the one on our test where if you plug in the x value here, if it comes out to a denominator of 0, then you're going to say it's not continuous. You don't have to worry about the types of continuity here, guys, but just for curiosity's sake, this is called a removable discontinuity. We'll learn more about that in an upcoming chapter. So you just tell me yes or no for continuity, just like we did on our test. So I'm sure those of you who asked that question, you were freaked out about the continuity test. So number 9 is very similar, except this time it's a piecewise function. So I want to warn you about the piecewise function because we just got done doing those, right? Even though your function is not defined on both sides, you still have to test both pieces. So this is if x is less than or equal to negative 6, and this one must be x is greater than negative 6. So they want to know if it's continuous at x equals negative 6. So you have to test both. So test both pieces by plugging in negative 6 here and here, and it's continuous if you get the same output value. So if you get the same y value of the answer, then yes, it's continuous. If you get different values, it's not continuous or discontinuous. And by the way, that's called a jump discontinuity if you run into that. And then number 31 on that same assignment, what does that say? And this is the one where you're supposed to, oh no, you don't ignore the instructions on 31, you just do the question, I guess. Oh, of course, the word problem, right? So they give you, you know what guys, oh, I thought we did this one in class. I was about to get angry that someone asked it, but I guess I did not. So the reaction rate is the speed at which it occurs is given by 0.5x over x plus 12. And they want you to graph it using a calculator, so you're going to have to watch your window, and I might suggest you also write down your window that you used when you go to graph this. A little sketch is fine, but please do provide the window. And then it says, what does the end behavior of the graph mean in context of the experiment? So I think this is a case where when you go to look at the graph, I don't know exactly what it looks like, but it kind of dies off as an asymptote. Because if you think about a chemistry experiment, when things are reacting, at some point the reaction has to stop. There's only so many limiting reactants that can go on. So you need to kind of pull out your chemistry brain there and give me a good answer to that part of the question. I'm not going to do that one for you. You guys get to have fun with that one. All right, the next page that people wanted me to look at was maybe on page 41. They said check out number 25. So let me check that out. Let me guess, it has 17,000 parts that you want me to answer, huh? So page 41. All right, so question number 25, and this is where they changed the directions on the blue sheet. They want you to sketch it in the appropriate window, find all the maxes and mins. Okay, you know what? Someone asked me this because they just wanted to see an example done. I'm just going to write a really sassy note here. You need to look at your notes. So sorry to be a jerk about that, but there's tons of examples of us doing this in our notes. You can go back and watch the lesson on 1.4, or you can look at the tan sheet. But on the tan sheet, we did a lot of estimating of points. You actually need to use your calculator to find your maxes and mins. So sorry, guys, I'm not going to do that question for you. You do it. All right, number 50, page 52. And this is the first page 52 assignment. So it's 1.5a. They wanted me to check out a couple questions here. Let's see. Now, that's a lot of questions on this list, guys. I don't think I'm doing all these, but I'll see if I can give you a little leg up on a few of them. 52. Let's see. All right. First, they asked for 25. Well, let me check it out. Identify the parent function, describe how they're related, and then graph them together. So, okay. I'm not going to do this question for you because it's really not that hard. I'm sorry. There are two transformations. So the parent is the super boring y equals square root of x. So you need to figure out what to call these two transformations. I'm not doing that for you. And then you need to graph the parent and this shifted one on the same axes. So you should be using graph paper on this assignment. So, sorry, I'm done with that one. All right, 43. Oh, let's see. They want, let's see, what's 143? 43 is a polynomial. It says f of x equals x to the 4th power minus x to the 3rd power minus 4x squared. And they want you to find two things. They want you to graph two things. So what you first have to do, I suggest you graph the original. And then maybe do that in pen, like black pen or pencil. And then once you have the original graphed, they're going to want you to do the absolute value of f of x, which if you look back at your notes, that means you reflect all the negative parts up to positive. So if you look at the answer key, which I took a photo, like a colored picture of it, and if you look at your notes for what this means, you'll know what I'm talking about. And then they also want you to do this one. Now this one's tricky. F of absolute value of x. That one's my least favorite one. So go look at your notes, but this is the one where you erase the left side, and then you're going to copy the right side again on the left side. So check out your notes, check out the key, and that's going to make more sense. There is no way I'm doing those questions for you, though. So that's like the only one you get to practice that. So do it yourself. Number 40, where's the next one? Lost my list. Oh my gosh. Okay. 45 and 49 were asked. So 45 is the same as 43, so good luck. And then 49 is, okay, so 49, where are we at here? It says, write a graph in the function with the given characteristics. So the original function they want you to consider is the 1 over x. And then it says it's got a vertically expanded by a factor of 2. So a vertical expansion or vertical stretch just means you throw a 2 in front of the function. So think about what that would look like if you threw a 2 in front of this function, okay? I'm not going to do that for you. And then it's been translated 7 units to the left and 5 units up. So remember, when you move left, you take your function, but instead of x, you're going to write down x plus 5 in that part. So right here. And then for, where are we at here? 5 units up. That means you have your function, which all of these two things have already happened to it. And then you're moving 5 units. Oh, choose. That was supposed to be 7. All right, so then plus 5 here. Sorry about that. Okay. Now, I didn't do that question for you. So you have to come back here, vertically stretch it by 2, move it left 7, and then it's got to up 5 off to the side. Again, look at the answer key. I think you'll figure it out once you get that down. All right, 49. That was the last one on that one. Now, there's questions on the Piecewise packet that I gave you. at the very end of it, if I can find this, there's two little questions kind of stuck at the bottom, and I think they're called 19 and 20. So 19 says, figure out what f of x minus 2 looks like. Well, think about what transformation that is. That means it's down 2 units. So you're going to take your graph and you're going to shuffle every single ordered pair. I would just do the corners. Shuffle them down 2 units and then connect all your dots again. And then for 20, you have a negative in front of your function. And then you're also shifting it to the right too. So because these two transformations, like this one's a vertical transformation and this one's a horizontal transformation, you can technically do them like any order you want, but I need you to at some point reflect over the x-axis, so a vertical reflection, and then I also need you to move all the points right too. Order is not going to matter in that question, so just make sure that you perform those two transformations to each of the corners, and then you'll have a new function to look at. All right, I think I covered them all. Good luck.